Hello, I'm Pratiksha, and in this video, I'll walk you through my entire RapidMiner workflow for predicting household energy consumption. We'll start by dragging all the operators into the workspace, then connect and customize each one, run the process, and finally interpret the results. Let's get started. First, I click on the operators panel and search for read CSV. I then drag the read CSV operator onto the blank canvas. This operator will load a raw data file. Next, I search for the replace missing values and drag that just to the right of read CSV. This operator will help clean any null or invalid entries. Moving on, I locate select attributes and drag it onto the canvas below replace missing values. Its job is to keep only the relevant columns for modeling. Then I search for set role and drag that next. This operator will designate which column is the target label. After that, I find split data and drag it down, which will divide the dataset into training and testing sets. Next, I search for linear regression and drag that onto the canvas. This is the machine learning model we'll train. I then drag apply model next to linear regression. It applies the trained model to unseen test data. Finally, I search for performance and drag that onto the canvas to calculate the RMSE. Now that all the 8 operators are on the canvas, I'll connect them in sequence. First, I click on the small circle at the right edge of the read CSV operator and drag it to the left input port of the replace missing values. We'll select the read CSV and we'll import this .csv file we are using in our project. Next, I connect the output port of the replace missing values to the input port of the select attributes. Now we select the replace missing values and go to the parameters panel. Now we're selecting the subset and we'll select every attribute except date and time. And now we'll replace the missing values which will be null or invalid to the average of the column. Now in the parameters panel of the select attributes, we're going to select all the attributes except date and time which is not directly used in our project. In the set role parameters panel, we are giving the attribute name as global active power and we are selecting the target role as label. From the set role, I connect to split data. In the split data, we are entering the values to be zero point 0.7 and zero point 0.3, which means 70% of the data is used for training and 30% of the data is used for testing. The split data has two outputs, example set 1 for training and example set 2 for testing. I then drag a connection from example set 1 to the input port of linear regression and then from the example set 2 to the unlabeled data input port of the apply model. Then I connect the model output of linear regression to the model input port of apply model. Finally, I connect the labeled data output of the apply model to performance separately. I also connect the output of the select attributes plot so that we can visualize the target distribution before modeling. At this point, everything is connected and configured. I click on the green Run button at the top. RapidMiner executes each operator in sequence. Once the run completes, I open the histogram result. This shows the distribution of global active power before modeling. We see most values clustered between 0 to 2 kilowatt with a long tail at higher values. The right skew distribution is typically for household energy data. I click into performance in the results panel. Here we see RMSE to be 0.042. An RMSE of 0.042 means that on average our model's predicted power consumption values deviate by only 0.042 kilowatts from the true values. Given that global active power typically ranges up to 5 kilowatt, this indicates high accuracy. This no-code drag and drop process in RapidMiner AI Studio makes it easy to go from raw data to a deployed predictive model. Thank you for watching.